I do this activity in a unit on solutions. Now, my students have already performed an experiment where they have prepared a saturated, unsaturated, and supersaturated solution. So the idea here is to give them a chance to review these concepts. Now, what I have up here at the chalkboard are some drawings, and these represent 3 beakers with solutions. My yellow circles here are going to represent crystals. So as we look at these 3 beakers, we notice in the first beaker, there are no crystals visible. In the second beaker, there are no crystals visible. But we do see crystals in that third and last beaker. So what I would do with my students would be to ask for a volunteer to come up and have them label these 3 beakers. In other words, to take our saturated, supersaturated, and unsaturated labels and place them underneath the appropriate beaker. Now, perhaps you have found that to get students to take part in this kind of come-to-the-board activity, you have to give them a little bit of an incentive. So what I do is I bribe them, and I'll say, this is what is known as a mole dollar opportunity. And what they do is they get these mole dollars, which they can cash in as bonus points on a test later on. So even though getting these is not going to create major changes in their grade, psychologically it's a really good way to get them to volunteer to participate in class, especially when they come up to the board. And the other thing is that I always make sure that they're never going to be embarrassed at the board. And they know that from the get-go, that I'll always give them leading questions or assist them. So it's never a humiliating situation. So right now, we're going to do this. I'm going to ask for a volunteer to come up out of the audience and ask her to pick these 3 labels and place them under the beaker that she thinks is appropriate. Very good. And I'll say to my students, I'll say, wow, how do you think that you knew which one to label here? And of course, the answer is that you really don't. Unsaturated and supersaturated solutions look the same. No crystals are visible. So just on looking at them, we cannot make that distinction. And here is your mole dollar for your reward. And you may take a seat now. So how are we going to be able to distinguish among unsaturated and supersaturated solutions? If we can't do it visually, then what we're going to have to do is an experiment. And that experiment is adding a crystal. So what we're going to do is drop a crystal into the beaker and see what happens to that crystal. So I ask for a second volunteer to come up, and we'll do the easy one first. I'll say, let's just drop one into the saturated solution. And we'll go through the motions of dropping it in off the top, and it just sits there, because after all, saturated is already holding all that it possibly can. So when you add another crystal, it's just going to be undissolved at the bottom. Okay, let's talk about adding one into the unsaturated now. Now remember that the unsaturated can still dissolve more. So when you drop it in, it's going to dissolve, so you've got to hide it behind your back. So you go through the motions of dropping it in, and then it disappears. Okay? And then lastly, we're going to drop a crystal into the supersaturated solution. And not only does that remain undissolved, but it forces out more crystals because the supersaturated solution was holding more than it possibly could. Very good. Okay, take a seat. Now, with my students, I'd say, as we're looking at them right now, does this label still apply? No, because what we have done is we've taken the supersaturated solution and we've actually destroyed it in the process of testing it. So actually now this becomes a saturated solution here. Now, this is a review. The students have prepared solutions of this type, but what I want to do is show them an application. This is one of the thrusts of my teaching. How can we take those chemical concepts and apply it to a commercial product? So we're going to come over here, and we're going to examine a product known as the heat solution. Now, this is a hand warmer, all right? This is a hand warmer, and let's just look at what it's made up of and how you actually use this. Now, first of all, as we look at it, if we ignore this kind of metal disc that's floating around in here, then do we see any crystals in there? No. So right away, if I said, what kind of a solution is this? We could eliminate saturated, because if it were saturated, we would see crystals. Now, if you actually read the contents, it tells you that it's sodium acetate, which is a white solid, and water. So we know we have a solution here, and we know that it's not saturated. So now what we have to do is test it to see if it's un- or supersaturated. But remember that the test was to add a crystal. And this is all sealed up. We don't have a crystal to add. But if you follow the directions on here, what you do is you flex the metal disc back and forth, and then we see the crystals forming. So, if flexing the disc, which is the same as adding a crystal, causes more crystals to form, then it must have been supersaturated initially. Is it supersaturated here now? No, because we can see the crystals. So we've taken this supersaturated solution and we have destroyed it and made it a saturated solution. Now, the directions on here say that it's usable. So I'm going to leave one of these aside, and let's take this and put it into boiling water. Because what do we know about increasing temperature of a solution of a solid in a liquid? Increasing temperature, in general, will increase the solubility of a solid in a liquid. So if we place this in the boiling water, our solid sodium acetate should dissolve. And it tells you that this takes 5 to 10 minutes, but with the tongs and some prodding, you can usually get this to dissolve a little bit more quickly than that. So, mind you, what we're doing here is regenerating our solution, because that's what it tells you, that this can be used a number of times. And by the way, I will mention here that the company claims that the limiting factor on this, and when this wears out, is when the plastic seal on it leaks. All right, so what do we have here now? We have a clear solution again, right? So again, the question is it unsaturated or is it supersaturated? Well, what are we going to do? We're going to flex the disc here. And so let me just do all the flexing. Is anything happening? Do we see any crystals forming when I flex that disc? No. So what does that tell me about this solution? It must be unsaturated. At the high temperature, at the hot temperature, we now have an unsaturated solution. What's going to happen when this cools down? When it cools back to room temperature, all that extra solid that we got to dissolve at the higher temperature is still going to be in there. And then we will have a supersaturated solution. So let's look at our 3 solutions again. This is our saturated, because we can see crystals. This is our unsaturated, because when we flex the disc, nothing is happening. And then, of course, this is one at room temperature now, and it is supersaturated. So again, with your students, it brings home these 3 concepts of saturation, supersaturation, and unsaturation, and it shows them a product that has some practical use. In fact, you might explore that with students. You know, they can stick it in their pockets when they're outside in cold winter weather. These were once shown on the sideline of an NFL football game that was played outside in the winter months. But the thing is, eventually, you can always regenerate and go back to your solution to start over again. And that's the beauty of this product, that it can be regenerated.